Okay, so let's start our chapter 3 discussion. So since chapter 3 na tayo, so it must be obvious that a month by now, midterm exam nyo na. No? Okay, so be prepared na lang. Okay, so let's talk about chapter 3, which is on gravimetric methods of analysis. No? So in this process, we're going to talk about how do we do gravimetry, no? So paano ginagawa yung gravimetric analysis, and ano yung mga key ideas that has to be remembered, no? Although yung iba medyo medyo blurry siya sa imagination kasi wala tayo sa laboratory, no, para ma-visualize sana, no. So sa ngayon, let's focus na lang on the terms, no. So puro terms lang muna tayo. So let's talk about chapter 3, no. So in gravimetric method of analysis, we said last time that this is a method of analysis that is dependent on the mass or the weight of your substances, diba? So depending on the mass and the weight of your substances, you can determine the number of particles you have there, the number of moles, and even the molecular formula can be obtained using gravimetric methods of analysis, no? So yun yung ginagawa dito. Just determine the mass change, and then you will determine the quantitative data from that, no. Okay, so in doing gravimetric analysis, there are two types, no, of executing this method. So the first one will be precipitation method, and the other one is the volatilization method. Okay, so let's talk about precipitation method. From the word itself, no, it suggests na mayroong precipitation. Okay, so if you could still remember the precipitation reactions, di ba? Naalala nyo pa ba yung solubility rules last semester? So, yun. What happens in precipitation gravimetric analysis is that you are making your ions precipitate, no? For example, yung silver, hinaluan mo ng ibang ions, no? So, pag pinagsama mo yun, mamumuo sila. Okay? So, kunwari yung lead, lagyan mo ng iba pang ions, no? Pwede sila mamuo, no? So, ganun ginagawa natin for this method, no? So, what happens here is that in precipitation methods, your analytes are being converted to a sparingly soluble precipitate, no? So, when you say sparingly soluble, that means mababa yung solubility niya. So, it also suggests na hindi siya hahalo sa water, sa liquid. So, bali kapag naging precipitate yan, what will happen is that it will settle sa bottom ng container kasi hindi na siya ions eh. Siya ay solid na. Okay? Kaya sparingly soluble na siya. Okay? So, mangyayari doon pag pinaghalo mo yung dalawang substance, mamumuo sila, and then eventually they will settle sa ilalim ng solution. Okay? So after settling your precipitate, no? So kasi pag ginawa mo 'yan, so kunwari inalo mo yung lead pati yung sulfate, so magiging kulay black lahat ng solution. Okay? Ganun kasi ginawa ko sa thesis. I don't know if may picture pa ako dito. Tagal na kasi nun eh. Okay. So, bali, gagawin mo, pag pinaghalo mo yung dalawang solution, then nag-react sila to form precipitate, you will wait until your precipitates settle sa bottom. Okay, so magsisettle talaga, makita mo sila dahan-dahan bumababa sa solution. And then eventually, magse-separate na yung clear part ng solution and the precipitate portion. So what's next is that you will filter it and you will wash it to further clean it, no? Yung precipitate, and then later on you can use your precipitates, no, to determine the mass, or pwede mo pa siya i-combust, etc., no? So ganun yung precipitation reaction. So ano yung underlying principle with precipitation analysis? Gagawa ka ng precipitation reaction so that your ions will be converted into solids or sparingly soluble precipitates, no? Solids na rin kasi yan eh. So yun, kapag naging they will settle down from the solution, And then you will filter it, you will wash it, and yun, you have your precipitates na. Okay? So, ganun lang yung precipitation reaction. When we talk about volatilization reaction, this is actually a combustion analysis, no? If you could still remember your stoichiometry last semester, we actually did volatilization reactions doon, no? Or combustion analysis, 'di ba? From the masses of carbon, hydrogen, kukunin mo yung empirical formula, then molecular formula. Yun yung principle dito sa volatilization reaction. Okay. So what happens here in volatilization method is that your analyte or your substances are being decomposed, no, to simpler molecules at suitable temperatures. No? For example, you're going to analyze the molecular formula of glucose from sugar. So gagawin mo, you will combust the glucose, and then the molecules of carbon, hydrogen, carbon and oxygen will be trapped, no, using special containers. Pakita ko kung paano. So, kapag nag-combust ka ng material, may magta-trap ng mga gases na yon, no? Yung for example, carbon dioxide, may matatrap yon doon sa container na yon. And then, you can determine the mass change, no? So, kung gaano bumigat yung isang container, that means ganun karaming carbon dioxide yung nandun, okay? And you can use that to determine the molecular formula or any other properties of matter, no? So, bali, ang nangyayari sa volatilization again is that you are combusting your substances. No? Susunugin mo yung substances mo into simpler compounds. Okay? Then, you will collect the products, no? Usually, gases yung products, and then you will weigh them, and yun, you can do calculations with that na. Okay, so next meeting natin ipapakita yung calculations ulit na. Although nagawa na yun sa Stoic. Okay, so ito yung isang example. So suppose you want to determine the concentration of acid dito sa solution na to. So kunwari pinaghalo mo yung dalawang substances dito. Pinasukan mo ng nitrogen gas. So nitrogen gas will react with the acids here, no? And then yung bubbles na mafo-form ng reaction na yan, or yung air na mafo-form from this reaction, they will be trapped in these containers, no? And then dito sa container na to, pwedeng bumigat to. So kapag bumigat yan, that means may natrap yung gas molecules from the reaction. Okay. Then after doing the reaction, pag tapos na yung reaction mo, ito titimbangin mo to. So pag tinimbang mo yan, you can determine the amount of carbon dioxide, let's say, no? So yan, you can do calculations na. Okay. So ganun lang ginagawa dito sa volatilization. So what happens is that you allow your reaction to form gases, no? So hayaan mo siya mag-form ng gas. Pag bumula-bula na yan, yung gas na yon, it will travel through through this tube, no? Papunta dito sa mga containers, no? Itong mga container na to, sila yung magko-collect ng gases na na-evaporate from this reaction. So yung gases, matatrap sila dyan. So as a result, bibigat itong containers natin na to. So pag bumigat tong containers na yan, you can determine the mass of carbon dioxide, no? You can determine the mass of water, and then you can do calculations with them. Okay? So ganun lang. Okay, so next meeting uli yung calculations for that. Ngayon, puro concepts lang tayo. Okay. So again, what are the two types of gravimetric analysis? So first type is the precipitation method, which involves the addition of ions so that precipitates will form. Okay. So in precipitates, solid chunks yan. Magsasettle yan sa bottom ng container. Then you can filter it. Then pwede na kayo mag-calculate from your filtrate. No? Pag volatilization naman, it involves the combustion or reactions involving formation of gases, no? So pag nag-bubbles yung reaction mo, yung gas na na-form nun is i-collect mo using special containers, no? So ito yung mga special containers natin. They will collect the gases from the reaction. Then you can determine the mass of the substances that are trapped in these vials, no? kunwari ito, dito yung carbon dioxide. So dito, kunin mo yung mass change, no? Kasi pag na-trap yung carbon dioxide dito, bibigat to. Okay, so by determining the mass changes, you can determine the mass of carbon dioxide, and then later on, you can use stoichiometry, no, to solve for the required stuff sa question. Okay, so ganun lang siya. Basically, inorganic chem lang tong ginagawa natin, no. Binibigyan lang natin ng emphasis yung process, no. So ganun lang yung precipitation and volatilization reaction. Okay. So when doing precipitation, there are properties of the precipitating agents that has to be considered. Hindi yung basta-basta ka lang maghahalo ng ions as mag-precipitate yun na yun. No. So kailangan may selection ka. Which of these ions, no, will form the best precipitate for your solution ba? Okay. So ideally, no, when doing precipitation reaction, your precipitating agent must be specific, no, and selective, no. So kailangan specific siya for that ions or specific siya for that analyte and selective lang siya for that analyte. Bakit? Kasi one of the problems with precipitation reaction, suppose natin marami kang metal ions diyan. Then kapag naglagay ka ng anion, kunwari may na-form na lead chloride, no? Ah, ano pa ba yung mga precipitate? Lead chloride, silver chloride, no? So, kunwari, yung mga yon nilagay mo yan, nag-precipitate sila, halo-halo na yung mass mo doon, no? So, instead of alamin mo yung mass ni lead lang from the solution, ang pwede mo pa madagdag na mass is yung kay silver, no? So, bali, kailangan, pag mamimili ka ng ions na ihalo mo sa solution mo para mag-precipitate yon, mamili ka ng selective lang for that ion. Yun yung purpose ng solubility rules, no? So, check mo doon, ano yung ions that will selectively precipitate with this ion. Okay, kunwari, si lead, si silver, nasa solution. So, hindi pwedeng chloride. Kasi kapag chloride nilagay mo doon, parehas magpe-precipitate yon. Mahirap na i-measure kung sino yung lead doon, sino si chloride, no? So, gagawin mo, mamimili ka lang, anong ion yung magpe-precipitate kay lead lang. Anong ion magpe-precipitate kay silver lang. Okay? So, ganun gagawin mo. So, when choosing your precipitating agent, ito yung hinahalo to carry out the precipitation reaction, it must be selective or specific to your analyte. No? So, kung ano yung ions na gusto mo, yun lang yung ipe-precipitate nyo. Okay? So, ito yung mga ideal characteristics ng precipitating reagent. No? So, ito yon. Kalista naman dito. So, una, kailangan kapag nag-carry out ka ng precipitation reaction with your precipitating agents, one, kailangan readily filtered and wash-free from contaminants. No? So, ibig sabihin, kapag hinalo mo na yan, kailangan mabilis lang siya i-filter. No? Kasi, if matagal yan ma-filter, matatagal lang ka sa analysis mo. That happened to me, no? Kasi, hindi ko alam kung anong ginawa ko no'n dati sa Anachem lab ko. May hinalo akong isang substance which is not so good for that ion, no. Although andun siya sa solubility rules, kaso nga lang, nag-precipitate din siya with other ions sa container ko, no, sa vial ko. So, nung nilagay ko yon, ang daming precipitates na namuo. So, nung fini-filter ko yon, ang tagal, no? So, it took me around 3 hours lang to finish the precipitation. Kasi antayin mo tumulo yung, 'di ba, effluent, yung liquid. So, inantay ko yung talaga ma-filter lahat, no? Until tapos na yung filtration, no? So, kailangan kapag kayo, mamimili kayo ng, precipitating agents, kailangan yung selective lang talaga para hindi sandamukal yung precipitate na mafo-form. Okay, para mabilis kayo matapos. Okay? So again, your precipitating agent must be readily filtered and wash-free from contaminants, no? Madali lang siya linisin and madali siya i-filter. Okay? Number 2, of sufficiently low solubility so that no significant loss of the solid occurs during filtration and washing. So, kasi, bakit kailangan natin consider yung solubility? Yung precipitates kasi natin, they are sparingly soluble, no? Yung word na sparingly soluble, that means soluble pa rin naman sila. However, to a little extent, no? Onti lang yung extent na madi-dissociate sila. Okay? So, ang ating ano kasi, ang ating precipitates, iba-iba yung kanilang equilibrium solubility product, no? I-discuss natin yung next chapter. Dun sa equilibrium solubility product, that is a measure kung gaano karami sa precipitate yung nagdi-dissociate, no? Ayaw natin ng precipitate na mataas yung solubility product, yung equilibrium solubility product, no? Ayaw natin yon. Bakit? Kasi kapag mataas yung equilibrium solubility product, what happens is that your precipitate will dissociate into ions. So nawala rin yung silbi ng precipitation reaction mo kung ang iyong ions ay magiging ions uli, no? So kung yung precipitate niyo magiging ions uli, no? So next chapter 'yon, yung solubility product. So again, ano yung point ko sa number 2? Kailangan yung ating precipitate, it must have low solubility or low KSP or equilibrium solubility product, no? KSP, equilibrium solubility product. Kailangan mababa 'yon. Kasi kapag mataas 'yon, pero precipitate 'yon, what will happen is that magiging ions pa rin 'yan, babalik pa rin 'yan sa original state niya, and we don't like that, no? Kasi ang gusto natin when doing gravimetric analysis is that lahat ma-collect natin, 'di ba? Ayaw natin na may mga natirang ions doon sa ating container, okay? So 'yan. So we must consider a precipitating agent that will give us low solubility, no? Kailangan yung 'pag pinaghalo mo sila, mababa solubility talaga nila, okay? So, para mag-precipitate sila lahat, okay? Kasi kung mataas yung solubility niyan, that means yung precipitate mo pwede maging ions uli, okay? So, ayaw mo 'yan. Gusto mo yung hindi siya mag-a-ions uli, okay? So, 'yun. So, una, kailangan yung iyong precipitating agents, no? Kailangan it must be readily filtered, mabilis siya ma-filter. And mabilis siya linisin, no? Kasi kapag matagal niya ma-filter, kayo yung matatagalan sa laboratory, okay? So you choose the ions, no, that is selective para hindi sandamukal yung precipitates na ifi-filter niyo. And next one is that you should choose a precipitating agent that will give you the lowest solubility, no? Lowest solubility, bakit? Kasi kapag mataas yung solubility ng precipitate mo, magiging ions uli yun. And you don't like that, no? Kasi ang purpose nga ng precipitation reaction is yung maging solid sila, not yung bumalik sila sa ions. Okay? So, yan. And this will be discussed in depth pagdating natin sa chapter 4. Andun yun eh. Sa equilibrium calculations. Number 3, your precipitate must be unreactive with constituents of the atmosphere. 'Di ba naging solid na yung precipitate mo? Ang mangyayari kasi nun, after mo i-filter, ido-dry mo yon, okay? So ido-dry mo siya sa air para mawala yung water kasi basa 'yon, 'di ba? So ido-dry mo siya sa air. The problem with other precipitates is that they react with air, no? For example, may oxygen sa hangin, pwede siya makipag-react doon sa precipitate nyo. Ano mangyayari nun? Ano effect nun? Tataas yung mass ng precipitate mo. So, pag tumaas yung mass ng precipitate mo due to the reaction of it with oxygen in the air, pag nag-react yun sa hangin, tataas yung mass. Ano yung result? Pangit yung measurement mo, mali yung result mo. Okay, tataas yung percent error mo. So, ayaw natin ng precipitates that is very reactive with the air. No? May mga ganun substances na. So, kasi kapag nag-react sila with the air, pwedeng tumaas yung mass nila. And as a result, that will give you false numbers. No? Mali yung mga numbers na makakalculate mo out of that. No? So, that means your precipitates must be unreactive with the air. No? And then, number 4, of known composition after it is dried, if necessary, ignited. No? So, kailangan, pag sinunog mo yan, no, ah, Hindi siya yung magliliyab, di siya yung bigla-bigla na lang sasabog, no? So, gano'n kasi ginagawa sa precipitation. After mo i-precipitate yan, if you want to dry it quickly, i-ignite mo yan, no? Susunugin mo yan to burn off the water, no? Para mas mabilis, no? Or i-dry mo siya. Kapag yan nag-react with heat, no? Kunwari, bigla yan sumabog, mali yon kasi magbibigay yon ng wrong results again, no? So, pag wrong result, ibig sabihin wrong calculations, makukuha mo doon. Okay. So, may ganun bang cases sa lab? Meron po, no? Hindi ko siya na-experience, no? Kasi ine-emphasize sa amin parati, piliin nyo yung the best, yung hindi magre-react sa hangin at hindi reactive sa init, no? Kasi baka mamaya, for example, may nitrate na nakahalo doon. Pag ininit mo 'yon, sasabog 'yon. Parang ano 'yan, paputok, no? So, ayaw mo ng gano'n na. So, bale gano'n lang. Pag mamimili tayo ng precipitating reagents, number one, it must be readily filtered, no? Mabilis siya ma-filter and madali lang siya i-wash, no? Ayaw mo yung sobrang daming filtrates na mafo-form. Okay? Kasi matatagalan ka. Number two, it must have low solubility. That means, solid na solid talaga siya. Kasi kapag mataas yung solubility niyan, it means na yung iyong precipitate nagiging ions uli. Ayaw mo yon, no? So, ang gusto mo is yung precipitate mo ay precipitate lang. Hindi siya babalik into ions. So, in other terms, it must be low in solubility, no? So, may mababa yung solubility niya. Okay. So, paano mo malalaman uli yung solubility? You will look at the KSP, no, or the equilibrium solubility product, no, which will be done next chapter. Okay? So, yan. Titignan natin yung KSP ng precipitate na mabubuo. Kapag mataas yan, wag mo pipiliin yun. Pag mababa, yun yung pipiliin mo. Okay? Kasi kapag low solubility, ibig sabihin, hindi siya babalik sa ions. No? Number three, it must be unreactive with the air. So kasi kapag nakapag-react yan with air, for example, sa oxygen in the air, tataas yung mass niyang precipitate nyo. So kapag tumaas yung mass ng precipitate nyo, mali yung calculations mo, no? Mali yung makukuha mong mga sagot, no? So yan. And number four, it must be ignitable or dryable, may ganun bang term? So, yung kaya siya i-ignite or i-dry without any other reaction. So, baka kasi mamaya sumabog yan, no? May mga ganong cases, no? So, yan. So, those are the four ideal characteristics of your precipitates, no? So, yan. Lahat naman yan nakikita yan sa table, no? May table kaming tinitignan. For example, the KSP table. So, doon namin malalaman kung low solubility yon. At doon din namin malalaman kung ano yon, kung yon ay the best, no? Kapag low solubility. Anong table pa pwede mo pagbasihan dito? Yung solubility rules, no? Di ba naka-table yon? So, sa solubility rules, mamimili ka ng ion that is selective towards your cation. Mamimili ka ng ion that will precipitate with one metal ion only, no? Kasi if it reacts with other ions, pangit 'yon, no? So, ayaw mo lahat na lang nire-reactan niya kasi mahihirapan ka later on, no? So, 'yun. So, ngayon, there is a fine line between precipitates and colloids, 'di ba? Kasi 'di ba tatlo yung ating characteristics, no, ng mixture. We have the homogeneous, heterogeneous, and the colloids, 'di ba? Nasa gitna yung colloids eh. Homogeneous mixture, that means yung iyong analyte ay nakadissolve sa solution. Okay? Nakahalo siya sa solvent. So, isang phase lang yon. So, iisang phase. Kunwari, liquid phase yan lahat. No? So, that's homogeneous solution. Pag sinabi namang heterogeneous solution, for example, ito yung precipitate in liquid. So, yung precipitate, makikita mo may layer siya sa ilalim. Yung liquid yung nasa taas. Okay? So, you see two distinct phases, no? Meron kang solid sa baba, may liquid ka sa taas. And in between the two, the homogeneous and heterogeneous, you have your colloid. Okay. So yung colloid kasi, that is the borderline between homogeneous and heterogeneous. Okay? So let's talk about them, no. So again, kapag precipitates, no, yung particles ninyo ay large enough, no, para mag-settle sa bottom. Okay? So it is also large enough, no, the particle size is large enough to be filtered. Okay? So that's why filtration yung ginagamit nito. Malaki yung mga particles kaya kapag finilter mo, matatrap sila sa filter paper, no. Kasi kapag maliit yung particles mo, tatagos lang yan. Okay? So yan. So kailangan kapag precipitates, malalaki yung particles mo. Okay? So as in pwede mo siya hawakan talaga, no? So yan, para madali mo siya ma-filter. Masi-separate mo siya from the solution. Ang problem with colloid is that since ito ay nasa borderline, no, nasa borderline siya ng homogeneous and heterogeneous. Since nasa borderline siya, that means yung particles niya ay mas maliit compared sa precipitate, no? So as a result, mas mahirap siya i-filter. Okay? So mas mahirap siya ma-collect, no? Ma-collect lahat, no? Kasi yung iba pwede tumagos sa filter paper kasi nga maliit yung particle size, no? Or pwede siya mag-coagulate doon sa filter paper. Okay? So ganun. So, ito yung mga factors about particle size. So, sabi dito, yung colloids, no, they do not settle down from the solution. Bakit, no? Kasi hindi sila solid, no? So, yung solid kasi, na precipitate natin, mag-create yun ng heterogeneous mixture, di ba? So, maghihiwalay yung solid sa liquid talaga. So, madali siya i-filter. The problem with colloids is that the particle size is in between homo and hetero mixtures, no? So yung particle size mo medyo maliit siya. So hindi siya ganun affected by gravity. So as a result, hindi siya magse-settle down sa baba. Okay? So halo-halo 'yun doon. So ano yung result nun? Mahirap siya i-filter, no? Bigyan ko kayo example ng colloid, yung gatas. Try nyo i-filter paper yung gatas. Matatagalan kayo. Okay, bakit? Kasi you cannot separate the milk molecules there, no? Hindi mo siya masa-separate agad, no? Para makuha mo yung liquid, then matira ay yung colloid mo. So mahirap siya i-filter paper. Okay? Kasi nga, yung particle size niya ay in between the homogeneous and the heterogeneous mixture particle size, no? So as a result, hindi siya magse-settle sa bottom. Ano pa yung isang counterpart nun? Yung particle size niya medyo maliit, no? So hindi siya agad matatrap ng filter paper. So yun yung problems with colloids, no? However, pwede naman yan remedyohan, no? So mamaya pakita natin kung ano yung remedy with the colloids. Okay? So again, colloidal particles, they do not tend to settle down from the solution. Bakit? Hindi kasi sila malaki, no? Hindi malaki yung particle size to be affected by gravity. So hindi siya ganun kalaki. Hindi malaki yung particle size, so hindi siya mahihila ng gravity. So that means nakahalo lang yun dun sa liquid. So as a result, mahirap siya i-filter, no? Kasi hindi agad nagse-separate yung liquid sa colloids mo. Okay? So yan. Second one is that the particles with dimension, nawala ako. The particles with dimension on the order of tenths of a millimeter or greater temporary disperse in liquid phase is called the crystalline suspension. Okay. So ito naman about particle size lang to. So basically about colloids lang din to, no? So yung particle size nila, usually that's tenths of a millimeter or greater. So they are called suspension, no? So bigyan ko kayo example ng mga suspension or ng colloid, yung mga antibiotic na powder na nilalagyan ng tubig, no? Na mainit na tubig para makagawa ka ng solution. So yan, that's a colloid, no, or suspension. May ganun ako kasi yung aso. Ay, yung pusa ko, pinapainom ko antibiotics dati. So yun, so mapapansin mo doon, thick yung liquid and mahirap siya i-filter, no? Trinay ko kasi i-filter yon, hindi tumatagos yung liquid from the suspension or from the colloid, no? So mahirap siya i-filter kasi yung particle size ay in between homo and hetero, so hindi agad siya makatagos sa filter paper. Okay? So ano pa ba yung mga kwento dito? The particles of a crystalline suspension tend to settle and can be filtered, no? 'Di ba kapag yung gamot sinettle mo lang siya sa gilid, no? Kunwari, yung antibiotic, 'di ba minimix yun bago gamitin. Kasi kapag di mo siya minix, nagse-settle yun sa bottom. So yun, kapag nag-settle yun sa bottom, mas madali siya paghiwalayin compared sa nakahalo siya doon, no? So yun, ano pa ba mga ganap dito? The particle size is influenced by experimental variables. Ito naman. So, kwento dito is that yung particle size natin ng ating precipitates or ng colloids, they can be altered, no, by changing the solubility, the temperature, or the concentration of your ions, pwede rin ng pH, no. So that means yung colloids natin, pwede natin siya palakihin enough, no, so that they will settle, no. For example, yung gatas, lagyan mo ng suka, what will happen? Yung milk molecules, they will start coagulating. So mas mabilis sila i-collect, no, from the liquid. Mas madali sila tanggalin. Okay? So yun. So the particle size of your precipitate and colloid can be altered by the following variables. Pwedeng solubility rules, no? Pwedeng temperature, initin mo yan, it will start coagulating, no? Pwede naman palamigin mo yan, so titigas yung mga ions agad, no? Pwede naman palitan mo yung concentration ng ions doon. For example, pH, no? If you increase the pH, pwedeng mag-coagulate yung colloids mo so that mas madali sila i-filter. Pwede rin naman at low pH, dun sila magko-coagulate, no? Example is the milk, no? Okay, so yan. So there are lots of factors na pwede natin gawin to maximize the collection of our substances ng ating filtrates, no? So yan. Ito formula din na natin to gagamitin. So we can determine from this formula the relative supersaturation of your particle size, no? So that means if mataas yung makukuha nating relative supersaturation, that means mas madali i-filter yung ating substance. Kapag mababa yan, mahirap i-filter yan, no? So hindi na natin gagamitin tong formula na to. Kasi marami na kayong equation na gagamitin sa susunod. Okay. So, let's talk about how the precipitates form naman. Okay. So, paano ba nagfo-form yung precipitates natin? Balik tayo sa precipitate. So, there are two ways in which your precipitate can form. We can have the nucleation and we can have the particle growth, no? So, what's the difference between the two, no? So, nucleation, meron kang nuclei, no? So, kumbaga, yung nuclei na yon, dun magi-start yung formation ng precipitate, no? And then later on, lalaki yung nuclei, no? Para magkaroon ka ng big precipitates, no? So, one example of which is yung mga crystals natin, no? For example, mga diamonds or yung mga gemstones natin. So, yun, naka-nucleation process yun. So, mag-start yun sa nucleus. So, maliit na molecule yun. Tapos, dun magka-clump yung ating ions, no? To form the crystal. Okay, so ganun. So isang malaking precipitate yan kapag nag-nucleation yan. For particle growth naman, ito ang nangyayari dito is hiwa-hiwala yung formation ng nucleus, no? So kanya-kanya, kalat-kalat sila. So ibig sabihin nun, hindi ganun ka-ordered yung ating precipitate dyan. So mabilis siya masira. So one example will be yung sugar, no? So kapag yung asukal, ginawa mo siyang sugar crystals, 'di ba, brittle 'yon compared sa diamonds or gemstone. Bakit? Kasi the precipitate for sugar crystallization is particle growth yung process niya. Kalat-kalat yung paglaki ng particles, no? So that's why may part na matigas, may part na malambot, no? So ganun. So yun lang yung minor difference nila. Pero still the same ang concept nila. So they will lead to precipitate formation, no? So nucleation, again, it will start from a small particle and then eventually lalaki yon. Isang malaking chunk lang siya ng precipitate. For particle growth, kalat-kalat yung paglaki ng precipitates. So as a result, magiging brittle yung precipitate mo. So ano pa rin naman siya, solid pero brittle, no? So imagine nyo na lang kapag nucleation, para siyang kristal, no? Diamond, gemstones, no? Pag particle growth naman, ito yung parang sugar, no? Pag namuo yung sugar. So may part na matigas, may part na malambot, pero still matigas siya, no? So ganun din yung sa precipitates natin. Okay? So yan. Okay. Ito pa yung isang way to control the particle size. Ito nga yung pH, no? Nakwento ko na pala kanina to. So, depending on the pH, your particles can grow or become smaller. So, ang target natin is that our particle will be big enough, no? So that they can be filtered, no? By the filter paper. Okay. Nakwento ko na rin tong coagulation of colloids. So, what happens sa coagulation is that yung colloid mo, pag nag-coagulate yan, magsasama-sama sila to form chunks, no? Solid chunks, no? Para siyang taho, no? So, ganun. From milk, may mabubuo na coagulates, no? Parang taho, no? So, yung taho na yun, yung taho-like substance na yun, yun yung pwede mo i-collect, no? To separate the milk particles from whatever is in the solution. Okay? So, yun yung one way na para makuha mo yung mga ions mo doon. Okay? So, coagulation tawag doon. That can be done by heating or adding ions, no? Such as acids, no? So, ganun. Ayan. So, ito yung visualization lang kung paano nangyayari yung coagulation. What happens here is that by introducing other ions, for example, acid, naglagay ka ng acid, nitrates, no? So, mangyayari, yung acids and nitrates mo, they will push the ions of your colloids, no? Ipupush nila para magsama-sama sila. Okay? So, naglagay ka ng suka sa inyong gatas. What the suka will do is that yung acid ng suka, itutulak niya yung milk particles para mag-clump sila together. Okay? So, yun. Itutulak lang nila para mag-form ng blobs yung milk particles. So, that is also true for other ions such as silver chloride, no? And iron 3 hydroxide, no? Colloids yung mga yun, eh. Lalagyan mo lang yun ng acid para yung colloids nyo mag-clump together, no? So, magdidikit-dikit sila. Okay. So, itutulak kasi ng acids yun para mag-join sila. Okay. So, ganun lang. So, those are the ways, no, para ma-collect mo yung colloids, no? Kasi mahirap nga sila i-filter. So, pagsama-samahin mo na lang. Tapos, pwede mo i-scoop yan, no? Imagine nyo na lang taho yan. Parang taho, no? Ganun yung mangyayari dyan. Ito naman, extension lang to ng picture na to. So what happens here is that kapag dinamihan niyo yung other ions, no, ibig sabihin, yung, for example, yung acid, no, ibig sabihin nun, mas lalaki yung particles ng inyong colloid. So as a result, mas madali sila i-scoop out sa solution. Okay? So yan. Ito naman, medyo malapit na tayo matapos, no? Medyo malapit na tayo matapos. Puro kwento lang naman to, eh. So, ito naman yung ways to improve the particle size and filterability. So, that can be improved by minimizing Q, maximizing S, or both, no? Ito yung nasa formula, although di na natin gagamitin yan kasi wala tayong values for that for now, no? Okay? So, yan. So, you can increase the particle size by increasing the concentration of your solute or decreasing the equilibrium solubility. Okay? So, ganun lang. So, damihan mo yung solutes mo, pababain mo yung solubility mo, yung KSP. So, tataas yung particle size mo. Mas marami kang makukuha na filtrates na. Okay. So, yan lang. So ito naman, these are other processes that happens when we do filtration. So co-precipitation. What happens here is that, di ba, nagpe-precipitate na tayo. For example, nucleation yan or particle growth. No? When your precipitate starts forming, what happens is that pwede tayong magkaroon ng co-precipitation. No? Ibig sabihin ng co-precipitation, other ions may join. No? Pwede sila sumama sa pag-form ng precipitates, no? Parang nakiride lang sila. So habang lumalaki yung particles mo, biglang umipit yung ibang ions. So masasama sila sa precipitation, na. Okay? So maraming uri ng co-precipitation. There is surface adsorption, mixed crystal formation, occlusion, and mechanical entrapment. So isa-isahin natin yung uri ng co-precipitation. When we say surface adsorption, what happens here is that your contaminants, no, yung ibig sabihin ng contaminant natin, yung other ions, pwedeng dumikit sila sa precipitate, no. 'Di ba lumalaki na yung ating precipitate. Tas kunwari may other ions ka, yung contaminant, pwede sila dumikit sa surface ng iyong precipitate. So that is surface adsorption, okay? So habang lumalaki yung precipitate, no, pwede dumikit siya sa surface. So yun yung co-precipitation process, no? Yun yung surface adsorption process, okay? So again, habang lumalaki yung precipitate mo, pwede dumikit yung contaminant sa iyong precipitate, no? Okay. Hindi lang yan sa precipitate, pwede rin yan sa colloids, 'di ba? Kapag naglalagay ka ng acid, lumalaki na yung chunk ng colloid mo, pwede dumikit din yung other contaminants, no, na hindi necessary sa iyong reaction. Okay? So how will you remove that, no? Paano mo tatanggalin yung contaminants kapag dumikit siya sa inyong colloid or precipitate, no? The purity can be improved by digestion. So ano yung digestion? Basically, what you're going to do is that you will react your colloid again or your precipitate again para maging ions yan. Then pag naging ions na yan uli, mo siya uli, ipe-precipitate mo uli, no? So uulitin mo lang yung process, no? In order na matanggal yung co-precipitates, no? Or yung contaminants, okay? So ganun lang. So again, sa surface adsorption, this is a process of co-precipitation wherein yung iyong contaminants or yung other ions, didikit sila sa particles mo. Habang lumalaki siya, dumidikit siya doon sa surface. Okay? So yun. Paano yan na-i-improve? Paano natatanggal yung mga contaminants? You can redo the precipitation. Okay? Ulitin mo siya uli. Gawin mo siyang ion. Then if precipitate mo uli. O kaya i-digest mo siya. I-react mo siya with other chemicals. Para maging ions uli. Then eventually, mag-form uli sila ng solid chunk. Okay? So ulit-ulit lang yung process na yan. Okay? So ito naman, mixed crystal formation. What happens here naman is that, for example, may crystal ka. Ang pwede mangyari dun sa crystal is pwede humalo yung ibang ion sa loob ng crystal, no? So ano ba itsura ng crystal? Ano yan? Para yung square. Nakalatis yan eh. So nakapaganito yung mga crystals natin. So pwedeng yung contaminants mo maipit sa loob, no? So, yun yung mixed crystal formation, no? Okay. So ito medyo mahirap to i-control, although hindi naman natin to na-encounter madalas, no? Kasi we do not form crystals naman usually in the laboratory. So ito yung mga common problems with gemstone making, no? Kunwari gagawa ka ng ruby, topaz, no? So yun. Ito yung isang problem. Pwedeng yung other ions, pwede kumapit sa loob ng crystal structure. Again, yung crystal structure, para lang yung blocks ng square. Okay? So, dikit-dikit lang yung blocks ng square na yan. Pwede maipit dyan yung ions mo. Okay? So, medyo mahirap yan kasi papangit yung quality ng iyong ion, ng iyong crystals, no? So, ano yung pwedeng gawing remedyo dyan? Pwede pabagalin mo yung crystal formation. Okay? Kaya usually nilalagay yan sa malamig na areas. Kaya nga 'di ba sa kuweba doon nagfo-form yung crystal kasi malamig, mabagal yung formation ng crystal. So, pure yung crystal na mabubuo mo. Okay. Kapag pinabilis mo kasi yung crystal formation, pwede ma-trap yung ion sa loob ng crystal. So as a result, papangit yung quality ng crystal mo. And the last two ay occlusion and mechanical entrapment. So occlusion naman, what happens here is that habang lumalaki yung crystal particle mo, may pocket of other ions na papasok doon sa crystals, no? So ang mangyayari doon is magiging brittle yung iyong crystals, no? Or yung iyong precipitate, no? So yan. So again, kapag occlusion, nagkakaroon ng pocket formation, no, ng contaminants, no? Kasi nga mabilis yung paglaki ng precipitates mo or ng crystal mo. So ano yung downside niyan? Downside is magiging brittle yung crystal mo, mabilis siya masisira, no? So ano yung ways to improve that? Pwede pabagalin mo yung pag-form ng crystals, no? So ilagay mo siya sa malamig na area, hayaan mo siya lumaki yung particle size in hours or days, no? So para walang occlusion na mangyari. So hindi magiging brittle yung crystal mo. And then the last one is mechanical entrapment. So what happens in mechanical entrapment is natatrap yung iyong crystals, no? So yung crystals mo natatrap sila sa loob ng precipitates, no? So may entrapment na nangyayari. So para rin siyang ganito, mixed crystal formation. So may naiipit lang din sa loob. So as a result, papangit yung quality ng iyong crystal. So magiging brittle sila. So they can be resolved also by slowing down the rate of precipitation formation, no? So hayaan mo na lang yan mag-stand sa solution for hours. Hayaan mo yan mag-form ng precipitates over time. Then dun mo na lang siya galawin. Okay? Kasi kapag minadali mo yan, papangit yung quality ng iyong precipitate. Okay? And then last one, nakwento ko na rin to kanina eh. Nakwento ko na tong part na to. So after mo mag-filtration or after mo mag-precipitation and pag-form ng colloids, ang next na gagawin mo is to dry or ignite your precipitates, di ba? So kunwari, ipinaghalo mo na yung dalawang ions mo, nag-form na yun ng crystals, nag-form na yung precipitate or ng colloids. What's next is that you will dry them and then you will filter them. Okay? After you filter, ignite them pala, sorry. So after mo i-filter yung iyong precipitate or yung iyong colloids, no, ang gagawin mo is that you will heat it, no, iinitin mo siya until you will get the constant mass, no. Ba't kailangan kunin yung constant mass? Kasi nga, may water molecules doon, di ba? And yung water molecules, pwede yan makuha from the air, no? Or doon sa liquid na pinagmula ng iyong precipitates, no? So, gagawin mo, iinitin mo siya for hours or days until you will get the constant mass. So that water will not interfere with your calculation. No? Kasi kapag mabigat yan due to water, mali yung calculations na makuha mo. So ito, ginagawa namin to for hours, no? Minsan days. Actually, minsan umaabot yan ng weeks, no? Ang experience ko na malala ay weeks, no? Isang buong linggo kami nagko-constant way, no? After namin gawin yung precipitation reaction, isang buong araw yon. Kinabukasan, until the next week nun, nagda-dry kami ng precipitates namin. So just to make sure that yung precipitate ay walang water, no, para yung calculation mo ay accurate, no. So yun. So ida-dry mo siya, i-heat mo siya, no. Other ways ito naman yung iba, pwede mo siya i-ignite, pwede mo siya sunugin, okay? Susunugin mo siya directly by heat, no. Aapuyan mo siya para mas matanggal agad yung water. Okay. May mga precipitate or colloids na mas okay sa drying, merong mga precipitate and colloids na mas okay sa ignition. Okay. So depende 'yon dito. Okay. So malalaman mo naman 'yun sa recipe ng methods na ginagawa mo if i-dry mo lang siya sa oven or i-heat mo siya. Okay. So pero ang idea dito is that you must remove the water or other volatile substances na nakahalo sa inyong precipitates or colloids, no? So that you will be left with your analyte, okay? Okay, so ganun. We can also record the thermal decomposition curves, no, using the Thermogravimetric Analysis, no. So it is a graph that looks at the changes of mass, no, depending on the temperature scale, no. So, ito yung itsura niyan. Pakita ko sa inyo yung sa thesis ko kasi nagganyan din ako nun eh. Teka lang, hanapin ko. Documents, thesis, the TGA. Iba yung application ko ng TGA dito, pero kunwari precipitation to. Kunwari lang ha. Scroll ko lang, daming pages eh. Okay, so kunwari ito. So this is a curve, no, in which makikita mo yung changes ng mass mo over temperature scale, no. So ito yung sa thesis ko. kunwari precipitate to kunwari may precipitate ako dyan. So, kunwari ang aking precipitate ay 13.5 milligrams. No? So, as you increase the temperature, lots of molecules can evaporate from your solution. Okay? Maraming pwede mag-evaporate. No? So, kunwari, pagdating ng 100 degrees Celsius, nakikita mo bumababa yan. That means yung iyong water ay nag-evaporate. So, itong pagbaba ng curve dito is because of the evaporation of water. And then, yung other curves dito, yung other steep curves, yung mabilisan ng pagbaba, pwedeng because yan of the pyrolysis, no? Pwedeng nabe-breakdown yung organic matter mo, no? So, as a result, maglalabas yan ng carbon dioxide, no? Or other gases, no? So, ang result nun, pag lumabas yung carbon dioxide or other gases, mas lalong bababa yung mass ng iyong substance, no? So, ito yung thermogravimetric curve, no? Pwede mo to gamitin sa precipitation reaction. So, kunwari gusto mo i-monitor kung anong ions yung mga meron dyan, no? So, anong molecules nandyan, pwede mo yung makita using gravimetric curves, no? So, kunwari mabagal yung pagbaba ng curve, ibig sabihin yan, water molecules lang yung natatanggal dyan. Mababa lang yan, water. Pero kapag yan ay steep curve, ibig sabihin yan, may other constituent yan na nasusunog. No? May other constituent yan na nasisira over this temperature range. No? Okay. So, yan. Iba kasi application na sa thesis ko, pero ito yung itsura ng thermogravimetric curve. No? So, ito naman yung for anachem. Okay, so kunwari ito, thermogravimetric curve of these salts. What happens here is that, ito, mababa lang yung pag-change ng curve. Ibig sabihin yan, yung water lang yung natanggal dyan. Then, eventually, nag-constant yan. However, for barium sulfate, tignan nyo. So, unti-unti bumababa, then may sudden steep dito. Medyo bumibilis yung pagbaba dito, no? So, ano yung pwedeng implication yan? So, dito sa part na to, itong mababang curve lang na to, ito yung pwedeng water lang yung nag-evaporate. Pero itong sudden drop dito, kaya bumaba papunta dito, pwedeng yun yung decomposition of sulfate, no? So, pwede ma-decompose yan to form sulfur dioxide. Ang matitira na lang dyan ay barium oxide, no? Maging BaO na lang yung matitira dyan. Okay? So, yan. Ito yung ginawa namin last year sa Anachem before pandemic, barium sulfate. So, yan. Sa una, mababa lang yung changes sa mass kasi water lang nag-evaporate. Pero eventually, yung sulfate mo, masisira yan. Okay? So, masisira yung molecule na yan. So, mag-evaporate yan from your precipitate. Ang matitira dyan ay barium oxide. No? So, ganun. So, ito naman, this is dehydrated aluminum. Okay? Then eventually, pag tinaasa mo yung temperature, yung water mo, yung hydration, matatanggal sila lahat. So you will be left with pure precipitate na aluminum oxide. Ito naman, ito yung isang example na maraming curves. Ito yung katulad ng sa thesis ko. So marami kasing pwedeng mag-break off from your molecule. Okay, so for example, you start with calcium oxalate na may hydration. So, itong first curve, mawawala yung water. Then, yung next curve, mawawala yung carbon dioxide. Then, sa next curve, mawawala uli yung carbon dioxide. So, you will be left with calcium oxide. Okay? Carbon oxide daw. Okay. So, yun. So, ito yung effect ng temperature sa ating precipitates. No? Bakit natin kailangan i-dry or i-ignite yung precipitate? Number one is to remove other volatile substances, no? Para matanggal yung mga gases, no? Such as water molecules, carbon dioxide, no? So that you will be left with pure precipitates na lang, okay? So yun. Itong process na to will take weeks, no? Or days, no? Okay? Then after nun, kunwari tapos mo na i-precipitate yung reaction mo, tapos mo na siya i-ignite or i-dry, nakuha mo na yung constant mass after doing the reaction, you can now proceed with the calculation. And yung calculation dito, stoichiometry lang to. Okay, so basically kung anong ginagawa natin last time sa stoichiometry, ito pa rin yung gagawin natin dito. Okay, so as long as master nyo yung stoich, wala tayong magiging problema. Okay, So yung quiz 1 yung actually may stoic problems akong nilagay doon na gravimetric analysis, no. So kung nasagutan niyo yung correctly, then kayang-kaya niyo itong quiz sa chapter 3, no. So eto, mabilisan lang natin titignan itong example na 'to. Marami tayong examples sa sa Thursday. Okay. May worksheet tayo sa Thursday. So for example, this is a gravimetric analysis na tignan natin. An iron ore was analyzed by dissolving this amount of sample in acid. So ito yung acid digestion. So ano yung gagawin mo dito sa acid digestion? What happens here is that yung iyong iron ore, 'di ba, isang malaking chunk yan ng lupa, yung iron ore. Lalagay mo yan sa acid so that magiging ions lahat yan, okay? So parang ito yung ginagawa dun sa sa surface adsorption, yung precipitation, no. So gagawin mo yung malaking chunk ng solid mo, tutunawin mo uli, no. So iyan yung ginagawa dito using acid. Then kukunin mo yung liquid na yon, yung from iron ore na nilagyan ng acid, siyempre tunaw na yon kasi acid yan, tutunaw talaga yan. So after nun, ang gagawin mo is that you will dilute your solution with water and iron 3 was precipitated with hydrous oxide, no? Okay? As the hydrous oxide. So, bali, ang gagawin mo dito is that yung iron mo, nabubulol ako, yung iron mo, i-react mo yan with a base, no? With sodium hydroxide, let's say, so that it will precipitate as iron oxide, no? So, yan. So, mamumuo yung iron oxide na yan. Okay, by the addition of ammonia then, no? Okay, so actually colloid to. By addition of ammonia, magsasama-sama yung colloids mo, then pwede mo na kunin yan. Pwede mo na makuha yung filtrate. So after cleaning your precipitate and your colloid, yung residue, ito daw, yung filtrate, inignite mo, sinunog mo siya at high temperature. So that ang matitira ay ito, this mass of pure iron 3 oxide. Calculate the percent iron and the percent iron 3 oxide in the sample. Okay. So bale, itong part na to, kwento lang niya yung buong precipitation reaction. Kwento lang niya yung gravimetric process. No? And that's usual. Okay. So basahin niyo na lang yan. Pero wala naman masyadong important details diyan. So ang ginagawa sa ganitong problem, kinukwento ano nangyari, ano yung steps na ginawa niya, ano yung mass, ano yung mga idea kung saan merong changes sa masses, no? So ganun. Ganito yung typical gravimetric questions, nobela. So kukwento niya muna ano yung pinagmulan ng precipitate, ano yung ginawa mo sa precipitate, no? Tapos after mo siya precipitate, ano ginawa mo uli, no? So syempre i-dry mo siya or i-ignite to get the final mass, no? So let's calculate daw for the percent iron and the percent iron mali ata tong subscript nila daw. Fe203 to. Okay. So in the sample. Ay, hindi tama pala yan. Teka lang. Check ko nga anong pangalan ng molecule na yan. Iron to iron 3 oxide. Okay. So this is iron to iron 3 oxide daw pala. No? So ito yung iron to iron 3. Ito yung present sa mga iron ore. Okay. So given naman yan, don't worry. So hindi nyo kailangan problemahin saan galing to. No? So ibibigay na lang nyo itong molecule na ito. And this molecule is present in iron ores daw. Sabi sa Google. Okay. So ganun. So hanapin muna natin percent iron. Then ang gagawin natin, ito, i-convert natin into this. No? Itong Fe203, ko-convert natin into Fe304 using stoichiometry lang. Okay? So, yan. So, if you want to determine the amount of iron 3 oxide, so gagawin mo yung mass, i-convert mo into moles. Yun naman yung unang ginagawa sa stoichiometry, di ba? So, the mass of your given substance, ito yon, ko-convert mo siya into moles of your given substance. Na? So, yun yung first process. Okay? Then if you want to determine the amount of iron, yung moles ng iron 3 oxide, i-convert mo yon into moles of iron. Ito yung ginawa din last time, 'di ba? So paano mo malalaman yung moles of iron from iron 3 oxide? Just look at the formula. So dalawang Fe dito, so that means 2 moles of Fe is equal to 1 mole of Fe2O3. Okay, so yan. Then you multiply it by the molar mass of the iron. So you will get the mass of the iron. If you want to determine the percent iron, you will divide the mass of your iron by the mass of your sample. Okay? Mass ng iron divided by this is the mass of your sample times 100, you will see that 33% of the iron ore is iron. No? 33% ng ore ay iron, bakal. Okay? So yan. So typical stoic lang yan. So what you will do is that from the mass of your product, no, ko-convert mo siya into mass ng iron, then eventually into percent iron. Okay? So stoic lang yan. Sa letter B naman, so 'di ba, ang sabi sa atin doon, from iron 3 oxide, hahanapin mo yung iron 2 iron 3 oxide form niya, yung Fe3O4, no. So ito kasi yung present daw sa ores, no. So gagawin mo, i-convert mo to into that. So what you're going to do lang is to write a chemical equation. This is usually given, okay? Yung mga chemical equation na yan, given yan. So ibabalance mo na lang yan, okay? So you will balance this, no? And then what you're going to do is that, 'di ba given to kanina, yung mass ng iron 3 oxide, i-convert mo lang siya into iron 2 iron to iron 3 oxide, no. So ito yung formula ng iron to iron 3 oxide. So convert mo lang 'yan, and then later on, if you want to determine the percent Fe3O4, that is the mass of Fe3O4, ito yung conversion natin doon. Okay, stoic lang to. Typical stoic stuff. Then, pagkakuha mo niyan, di-divide mo yan sa mass ng sample mo times 100. And then, you will get the percent by mass of your iron 2, iron 3 oxide na, sa iyong ore. Okay? So, ganun lang. Typical stoic lang. Okay? So, ganun lang mangyayari sa atin. So, again, paano yung itsura ng question sa gravimetry? Okay, so ganito yung typical setup ng story niya. Ikukuwento niya saan galing yung gagamitin mo sa experiment, ano yung unang mong ginawa, okay? Ano yung mass ng sample mo, tapos paano mo siya precipitate, then after precipitation, ano ginawa mo, ito na yung part na yon. And then later on, papag-solvein ka na niya to solve for the percent iron and the percent iron 3 oxide. So don't be intimidated by the words dito. Kasi pag board exam yan, 2 paragraphs yan madalas sa amin. Okay? Pero sa ating subject na to, 1 paragraph lang. No? So yan, ang kwento lang naman sa first part is yung buong process ng precipitation, yung mga pinagkukwento ko kanina. Paano siya ginawang paano siya ginawang precipitate, ano ginawa sa precipitate after, inignite ba or deny, no? So ikukuwento niya lahat 'yon kasi ganoon talaga siya. Ang dami siyang gusto i-share. Then eventually, yung ipapasolve sa inyo, they can be answered by stoichiometry lang, okay? So ano lang yung nangyari dito sa chapter 3 natin. Basically, what we did for this chapter is that i-discuss lang natin yung steps, no, sa una, how to carry out the precipitation, and then later on yung last part ng problem ay puro stoichiometry na lang uli, okay? So ganun lang, stoic lang yan okay? So yan. So if you want to determine the mass of iron from iron 3 oxide, stoic lang yan, convert mo yung iron 3 oxide to moles of iron, then multiply mo yung moles into mass, you will get the mass of iron, divide mo yan sa original mass ng sample mo, you will get the percent iron. So kung gusto mo naman siya gawing iron to iron 3 oxide, ito yon. So may chemical equation na ibibigay sa inyo that is given mostly ha. So ibibigay sa inyo yung formula, ibabalance nyo na lang, then i-convert mo ito into this one. Stoichiometry pa rin, no? And then you will get your final answer. Okay? So saan ginagamit yung gravimetric analysis? So ginagamit yan if you want to determine the ions and the cations in your substances. If you want organic molecules to be analyzed, pwede rin, no? Kunwari gusto mo malaman yung molecular formula ng organic molecule, pwede gravimetric analysis yon, volatilization yan, no? Susunugin mo yung substance, then makukuha mo yung carbon dioxide and yung water na i-release niyan. Okay? Thus, from those masses, pwede mo makuha yung formula ng iyong organic substance, no? Uh, Ito pa yung maganda with gravimetric analysis, no? It does not require calibration or standardization steps, no? Kasi mass mole relationship na lang gagawin mo diyan, no? So hindi mo na kailangan i-consider yung changing ng volumes because of temperature, di mo na kailangan i-calibrate yung iyong yung volumetric flask kasi hindi ka gagamit ng measurements using those apparatus. Mass lang kasi yung kinukuha dito. So, hindi mo na kailangan i-calibrate yung mga ginagamit mo except for the timbangan. Okay? So, yun. Ito yung pinaka-easy pero pinaka-matagal gawin na chemical experiment. Okay? So, yun lang. So, marami siyang application. Pwede mo ito magamit for inorganic substances such as salts. Pwede sa organic substances to get the molecular formulas. No? And the best characteristic of this method is that it does not require calibration or standardization. Direct na to. Kung ano yung mass na makuha mo, yun na yung amount of substance na meron doon. Okay? Pwede mo na lang siya i-convert stoichiometrically. Okay? Ito naman. About naman to sa mga precipitating agents, no? So kapag inorganic yung substance na ipe-precipitate mo, you usually convert your ions into salts or oxides, no? Okay? So i-convert mo siya into salts or oxides, no? Pag organic naman, gusto mo siya i-precipitate instead of volatilization, then there are other ions that you can use para mag-precipitate yung organic molecule. No? Kung ayaw mo lang ng volatilization. So some of the precipitating agents for organic molecule is the hydroxyquinoline. Okay? So yan. Kakabit yan sa organic molecule mo so that it will clump together. Dimethylglyoxime, DMG. So yan, pwede yan kumabit sa iyong organic molecules, no? Para mag-precipitate yan. And ito, sodium tetraphenyl borate dimethylglyoxime. No? So yan, pwede mo to gamitin to precipitate ions or organic molecule as well. Although hindi na natin di-discuss masyado yan, ha? Ano na yan, pang-BS Chem na masyado. Okay. So, basta ang idea lang dito is that you can, other than ions, pwede ka rin gumamit ng ibang molecules to do the precipitation reaction. Pwedeng hydroxyquinoline, dimethylglyoxime, and the sodium tetraphenyl borate dimethylglyoxime. No? So, yan. For volatilization method naman, ito nakwento ko na to. Basically, what you're going to do is that you will combust your substance into gases, no? So, pag after combustion, ang mabubuo doon ay water and carbon dioxide, no? And then, yung water and carbon dioxide, kukunin mo lang yung mass, then i-convert mo sila into moles, then eventually to empirical mass, no? So, again, yung calculations, next meeting na lang, no? So, next meeting yung calculations. So, ngayon, summarize na natin yung pinagagawa natin today, no? Kasi ang daming info, no? Siguro na ano na kayo na, ano nangyayari? Okay lang yun. Kasi dami kasi talagang kwento dito. Tsaka ang hirap din ipa-visualize kasi wala tayo sa lab, eh. Okay. Pero anyway, so balikan na lang natin uli para ma-refresh yung mga ideas na sinabi ko kanina. Okay? So, ano uli yung gravimetric analysis? Ay, ba't tayo mag-full screen? Ganyan na lang. Wait lang. Close natin. Sir, kailangan ko ba kabisaduhin lahat yan? Hindi naman. Hindi mo kakabisaduhin lahat. Ang key ideas lang yung kailangan mo kabisaduhin dito. Ano yung difference ng precipitation sa volatilization? So, yan. Kailangan mo alamin yan. So, ano nga ba yung difference nila? Pag precipitation, ire-react mo yung iyong ions to form precipitates. Magiging solid sila. Okay? Pag volatilization, gagawin mo doon yung iyong molecules, susunugin mo to form carbon dioxide and water. Okay? Okay, so ganun lang. Yun yung difference nila. Okay? Paano ginagawa yung volatilization reaction? Basically, you will do your reaction or pwede mo sunugin yon. Then, yung gases na mapoproduce niyan, mako-collect using these U-tubes, no? YouTube talaga tawag dyan. Then, kung ano yung changes sa mass dyan, you can do stoichiometry out of that. Okay, pwede ka mag-stoich. Kunwari, nakuha mo dito, mass ng carbon dioxide. Pwede mo yun i-convert into empirical formula ng molecule. So, pwede yan. Okay? So, tuturo ko next meeting kung paano yung calculation na yan. Okay? So, also, when we are doing gravimetric analysis, we must check, no, kung ang ating ions ay selective, no, and specific for our ions. Kasi kapag hindi selective or specific yung ating pinili, sandamukal na precipitate ang pwede mabuo. No? Ayaw natin yun kasi, again, isa lang yung gusto mo alamin eh. Pag inalam mo lahat, mahirapan ka. No? Isa-isa lang, okay? So, kailangan pag mag-precipitate ka, itong ion muna, no? So, yung ion lang na ito yung ipe-precipitate ko. Kung gusto mo alamin yung ibang ions, then gamit ka ng iba pang sample, no? Okay? So, hindi pwede pagsama-samahin mo yung inaalam mo dito. Isa-isa lang, okay? So, yan. So, ito yung mga characteristic ng ating precipitate. Una, kailangan madali siya i-filter kasi kapag hindi, kayo mahihirapan. Kailangan mababa yung solubility kasi kapag mataas yung solubility niyan, yung precipitate nyo, magiging ions din yan. Ayaw nyo yon. Kailangan solid talaga yan eh. No? Kasi baka mamaya pag finilter mo yan, naging ion sila, di wala ka na filter. So, kailangan yung solubility niya ay mababa talaga. Also, it must be unreactive with the air, no? Kasi may mga may mga precipitates na nagre-react sa air. Ang result nun tumataas lalo yung mass, no? Pangit 'yon kasi mali yung makukuha mong mass, no? So, pag mali yung mass na makukuha mo, mali yung moles na makukuha mo, mali yung percent element na makukuha mo, and so on. So, basically, mali na lahat ng nasa-solve mo. Okay. So, ayaw mo ng precipitate na reactive with the air, no? And pwede mo naman i-check yung reactivity ng precipitate mo sa internet, no? So, ginugoogle lang namin yan, no? We check the MSDS, ganun. Then, after mo i-precipitate yan, kailangan ignitable yan and dryable, kung may ganun term. So, susunugin mo yan, iinitin mo yan so that ma-wear off yung water, no? Matatanggal yung water from your molecules, no? So, yan. Kailangan hindi siya reactive sa heat, no? Kasi baka mamaya sumabog yan, delikado. Okay. So, when doing precipitation reaction, dalawa yung pwedeng outcomes. Pwedeng may precipitate ka, pwedeng may colloid ka. So, yung colloid, this is in between homogeneous and heterogeneous mixture. Nasa gitna yan. Isipin nyo gatas yan. Pag colloid yung na-form sa inyo, medyo mahirap yan i-filter. So, mahirap siya i-filter compared to the precipitate na solid. So as a result, if you want to make your colloids, no, to be collected, mas madali siya ma-collect, no? Kasi hindi mo siya ma-filter agad kung gusto mo i-collect yung colloids mo. Then you can do several techniques, no, para magsama-sama yung colloid mo. Pwede lagyan mo siya ng suka, no? Lagyan mo siya ng acid, lagyan mo siya ng base so that they will clump together. Tapos yung clumps na yon, pwede mo yun i-scoop, no, using spatula. So, yun. So, pag nakuha mo na yon, ito-dry mo na siya. Okay? So, ganun. Pwede naman baguhin mo yung temperature. Kunwari, yung gatas, ininit mo, magko-coagulate yon. Yung namumuo na yon, yun yung pwede mo gamitin for analysis. No? Okay? So, pwede mo rin naman pabagalin yung process. No? Hayaan mo lang siya mapanis. No? Hayaan mo lang siya masira. Mamumuo yung colloids nun. Okay? So, ganun lang. Ito yung when precipitates form, dalawang uri yung pwedeng mabuo. Pwedeng nucleation, pwedeng particle growth, no? Pag nucleation, may isang site lang kung saan lalaki yung particles. Pag particle growth, maraming sites kung saan pwede lumaki yung particles, okay? So kapag nucleation, ito yung matibay kasi homogeneous yung pag-form ng crystal. Okay, so ibig sabihin solid talaga yan, para yung gemstone. Pag naman, particle growth, ang ganap naman dito is that kalat-kalat yung paglaki ng particles. So, as a result, medyo brittle yan. Okay? Pero, ang idea is that they will still form precipitates naman. Okay? So, mamumuo pa rin yan. Pwedeng matigas, pwedeng hindi siya matigas. Okay? So, depende yun sa paglaki ng iyong particles. No? Pwedeng nucleation or particle growth. So, ito naman, these are the factors that can be helpful no, if you want to make your particle size bigger. Pwede baguhin mo yung temperature. No? Pwede mo baguhin yung pH, no? Para mas lumaki yung particles. For example, sa colloids, no? Pag inilagyan mo yun ng acids, no? Baguhin mo yung pH, lagyan mo ng acid, lalaki yung colloids mo. Okay? So magka-clump 'yon. Mas madali sila makuha. Okay? Ito yung itsura ng process na 'yan. Okay? So basically kapag naglagay ka ng other ions such as acid, magka-clump together lang yung colloidal particles. Magsasama-sama lang sila. So pwede mo na sila i-scoop no? Instead na i-filter mo sila. Okay? So ganun lang. Ito naman yung mga problems with precipitation. Pwede tayong magkaroon ng co-precipitation. Ano yung co-precipitation? Yung ibang ions or yung ibang substances, pwede sila humalo sa iyong reaction. So, kapag humalo sila sa reaction mo, ayun, pwede kang magkaroon ng problems with your crystals no, or problems with your precipitation. And they can be resolved naman. Surface adsorption, what happens here is that yung contaminants didikit siya sa surface ng precipitate mo. So, kakabit lang siya. So, as a result, tataas yung mass ng precipitate mo. So, if you want to remove that contamination, ulitin mo na lang yung precipitation. So, i-acid digest mo uli yan. Tapos, ipe-precipitate mo siya uli. Okay? Mixed crystal formation naman, ito naman yung common sa crystals, no? Such as mga gemstones. What happens here is that yung ibang ions, yung mga contaminants, pwede sila umipit sa loob ng crystal. And as a result, masisira yung structure ng crystal. So, magiging brittle sila. Hindi na siya high quality. Okay? So, ano yung pwede mo gawin dito? Pwede pabagalin mo yung crystal formation. For example, yung mga crystal sa kuweba. So, it takes thousands of years no, para maging pure crystal yon. So, kailangan kasi mabagal. Kapag minadali mo yung pag-form ng crystal, pwedeng yung contaminants pumasok sa loob, masisira yung crystals mo. So, occlusion and mechanical entrapment, ito, similar lang to. What happens here is that yung contaminants pwede pumasok sa crystals mo. Parang ito lang din. Okay? So, ano yung pwede natin gawin dyan sa tatlong yan? Pwede gawin mo, pabagalin mo yung pag-form ng crystal, no? So that hindi makakapasok yung contaminants, no, sa iyong crystals. Ito nakwento ko na to. So after mo gawin yung precipitation reaction, next na gagawin mo is to dry them and to ignite them. Okay? So depende yan. So may process na pwede mo i-ignite, may process na pwede mo i-dry lang. Okay? So depende sa characteristic ng iyong precipitate. No? So, binibigay naman yan usually. So, hindi nyo kailangan kabisaduhin yan always. Okay? So, minsan, if you feel, i-dry mo na lang yan sa air o kaya i-ignite mo. Okay? And kung kukunin mo yung thermal decomposition yan, we call that the Thermogravimetric Analysis. Ito yung graph kung saan makikita mo yung mass and the temperature changes. No? So dito sa Thermogravimetric Analysis, pwede ka magkaroon ng idea ano nangyayari kapag sinusunog mo yan. So kapag onti lang yung kapag simple curve lang yan, pag isang mababang curve lang yan, usually evaporation ng water lang yan. So ito, evaporation of water. Pero kapag yan ay may maraming curves, multiple curves yan, ibig sabihin there are other chemical reactions that is happening. So for example, ito, evaporation of water, then ito, matatanggal na yung carbon dioxide, then tatanggal uli yung carbon dioxide. So, you will be left with the calcium oxide. No? So pwede mo maya malaman using thermogravimetric analysis. No? Okay? And then, again, kung ano yung mass na makuha mo after drying your precipitate, you can use that to do calculations. No? So, basically, stoic lang yan. So, stoic lang yung ginagawa natin dito. Saan ginagamit yung gravimetric methods? Sa pag-identify ng ating ions, inorganic ions. Pwede mo rin yung gamitin for organic molecules, no? Para malaman mo yung kanilang formulas. Okay? And ito yung mga iba pang ginagamit na precipitating agents. Okay? So, yun lang. So, that's all for today. So, kailangan nyo po ba kabasaduhin lahat to? Hindi naman. Ang kailangan nyo lang alamin dito is yung mga key ideas, no? So, ano yung difference ng precipitate sa volatilization? Ano yung ideal characteristic ng precipitate, no? Ano yung colloid? How do we address the issue of colloids? Paano mo siya tatanggalin? Nandito na yun, nakalista na yun, sinabi ko na yun. Sa pag-form naman ng precipitate, ano yung dalawang uri ng process sa pag-form ng precipitate? Okay? So ano yung difference nila? Then paano mo ma-control particle size, no? So paano mo ma-form yung coagulation ng colloids, no? So nakwento ko na naman lahat, no? So basically andito na sa PowerPoint lahat. And ano yung mga problems when doing precipitation reaction? So ito lang 'yon. Okay? So, alamin nyo na lang yung key ideas nila. Then, yan, after mo i-precipitate sila or i-coagulate, then ano yung gagawin mo next? I-dry mo siya or ignite, no? And then, yan, you can do calculations na. Okay? So, next meeting, gagawin natin, magfo-focus na tayo sa sa overview ng lahat. Okay? So, I will give you several problems, siguro mga 10 questions ulit, no? Bibigay ako ng 10 questions for gravimetric analysis. 5 doon, sasagutan ko yung 5, kayo na bahala doon. Bibigay ko naman yung answer key after, no? So, ganun. Basta ito lang yung tip ko sa inyo, kasi dito maraming bumababa yung score sa gravimetric analysis, no? Ang sasabihin ko lang talaga sa inyo is ganito lang. Pag nakakita kayo ng mga problem na ganyang kahaba, yung ibang questions, yung ibang sinasabi diyan, lang 'yun, okay? Kuwento lang 'yun. Okay, so for example, itong question na 'to, itong first 3 sentences, lang 'yun, okay, kuwento lang 'yan. Kailangan mo lang kunin do'n is yung mga mass, okay? Kinukuwento lang kasi diyan yung process, ano nangyayari, okay? So basically yung nangyayari diyan, nakuwento ko na rin naman kanina, 'di ba? So anong gagawin mo kapag mag-gravimetric analysis ka? Okay, so 'yan. So itong first part na yan, kukwento niya lang kung anong ginawa niya sa yung sample. Then later on, pagsa-solving ka niya. Yung solving naman dito is stoichiometry lang. So huwag kayo masyadong matakot. Okay? So pag nakakita kayo ng ganyang kahabang question, stoic lang yan. Okay? So lahat naman, actually, itong buong entire anachem, puro stoic lang to. Okay? So basta wag lang kayo magulat sa questions ha. Baka isipin niyo, ang haba niya, ang hirap niya. No, madali lang yan. Kaya niyan. Okay? So, ganun lang. So, next meeting na lang yung problems, no? So, for now, kain na muna tayo ng lunch, no? And thank you for attending. By the way, yung ating quiz 2 ay open na uli, no? So, sagot na yung mga hindi nakasagot. Okay? So, magsasara din yan agad, no? So, yan. So, galingan nyo po, no? If you have problems pala with the quizzes, no, message nyo lang ako. Kunwari, bigla kayo na lock, no? Biglang nag-close yung laptop nyo, sabihin nyo sa akin, no? Para maayos natin yan. Okay? So, yun lang. Would there be any questions or okay na tayo for today? By the way, yung PowerPoint nasa Canvas, So, kung kayo magsusulat ng notes, okay lang, no? Pero, pwede naman i-highlight nyo na lang yung words sa PowerPoints, no? Sa PowerPoint. Andun naman yung mga, definition, yung definition, yun lang naman kailangan natin dito sa chapter na to. Yung solving, yun yung kailangan natin i-focus, no? Next meeting. Okay? So if there's now any questions, let's call it a day. Kain na tayo ng lunch, no? So I'll see you again this Thursday, no? Para magsagot tayo. Okay? And so thank you po and ingat na. Again, yung mga keywords, yung key ideas dito sa lesson natin, paki-note na lang, okay? So yung differences lang. Kasi may ganun sa quiz ulit, no? Okay, so ganun lang. Next meeting, focus tayo sa calculation. So I'll see you again next meeting. So bye-bye and ingat, kain na po ng lunch.